Hello everyone, welcome to our new lecture. Now, from this lecture, we are going to start our chapter number 5, and that is acids, bases, and salts. So, definitely, we are going to see what is acid, what is base, and what are the salts. Okay, so in this chapter, we are going to discuss Arrhenius theory of acids and bases. We are going to see the concentration of an acid or a base. Then we will see what is pH and how it can be used to identify whether the given compound is acidic or basic in nature. And then we will see briefly what are the salts and what type of salts we use in a regular basis. Now let's start with the question which is given over here. How are the following substances classified into three groups with the help of litmus? Okay, so you may have seen or studied about this litmus or litmus paper or litmus solution, okay, that can be used to identify whether the given substance or the given compound is acidic or basic in nature, okay, and it can also identify whether the substance is neutral or not, okay. So here some examples are given: lemon, tamarind, baking soda, buttermilk, vinegar, orange, milk, lime, tomato, milk of magnesia, water, and alum. Now, definitely, some of the material from this are acidic in nature and some are basic in nature, whereas some may be in neutral state. Now, this lemon, it is in acidic in nature, then tamarind is also in acidic in nature, baking soda, it is basic in nature, then buttermilk, again acidic in nature, vinegar, okay, it is acidic, then orange, it is acidic, milk, acidic, lime, it is acidic, tomato, acidic, milk of magnesia, I don't know whether it is acidic or basic for sure, but I think it is basic in nature, then water. Now, generally, the pure water is neutral, okay, which have the pH value equal to 7, and it is neutral. So now we will say that this water is pure water. So if it is pure, then it is neutral. Okay, and alum, it is basic in nature. Now we have seen earlier that the some foodstuffs are sour to taste while some others are bitter and slippery or soapy to touch. Okay, some of the foodstuffs are sour to taste and some are bitter. Okay, so the substances which have sour taste are generally acids or acidic in nature, and the substances which have a bitter taste are basic in nature. Okay, other property which is given here for bases are that these substances are slippery and soapy to touch. Now, when these substances are studied scientifically, it is found that they contain acidic and basic substances respectively. So acid will have acidic substance and basic will have basic substance. Okay. We have also learned about an easy and safe method of using an indicator like litmus to detect acids and bases. So litmus, okay, which is made up of lichen, a plant, okay, it can be used to identify whether the given compound is acidic or basic in nature. Okay, now we can use litmus paper or litmus solution. There are two types of litmus solution: blue litmus and red litmus solution. Okay, we will look into it in briefly in this chapter. We shall now learn more about acids and bases first. Okay, you must know what is acidic compound and what is basic compound. Now, in this table, you can see molecular formula of several compounds are given over here. Okay, we have to note down the name of that compound. We must know what is the basic radical and what is the acidic radical, and we must name the type of the compound. So first is done for us. Okay, that is HCl. The molecular formula HCl is of hydrochloric acid. The basic radical is H plus ion and the acidic radical is Cl minus ion. Now let me tell you that the positive radical is nothing but basic radical in a compound, and the negative radical or the element which have negative sign is nothing but acidic radical. Okay, and both are nothing but ions of the compound. So H plus ion and Cl minus ion. Okay, this has a positive charge and chlorine has a negative charge. As hydrogen has a positive charge, that means it has donated one electron to chlorine. Okay, so the ion or the element which is going to give its electron to other element, okay, it will carry a positive charge, and the element or the ion which is going to gain the electron, okay, which is not going to give, which is going to receive the electron, okay, that is a negative ion or a anion. Okay, now this negative ion is acidic radical and the positive ion is a basic radical. Now second example, the molecular formula is HNO3, so that is nitric acid. Okay, write down the name over here, nitric acid. And then the basic radical in HNO3 is H plus ion, and the acidic radical is NO3 minus. Okay, so NO3 minus is the basic radical, sorry, acidic radical, and H plus is the basic radical. Now whatever compound which have H plus as a basic radical, okay, which have the H plus ion and it is the basic radical, so all those compounds are categorized in acid. Okay, so as this compound have H plus ion, it is an acid. Okay, it is acid. Now next it is HBr, so hydrogen bromide, compound name is hydrogen bromide. The basic radical is H plus again, okay, and the acidic radical is Br minus. Okay, type of the compound, again it is acid, as H plus is there as a basic radical, that means this compound is also acid. Okay, next is H2SO4, so that is sulfuric acid, okay, here. Then the basic radical is H2 plus ion and the acidic radical is SO4 minus. Okay, so SO4 minus is the acidic radical and H2 is basic radical, and it is also an acid. Okay, sulfuric acid, so it is also an acid. The next is H3BO3. Okay, so this is boric acid. Okay, H3 plus is a basic radical and BO3 minus is a acidic radical, and it is also an acid. Next you can see NaOH, sodium hydroxide. What is the name of the compound? Sodium hydroxide. The basic radical here is Na plus. Okay, so Na plus is the basic radical. Okay, and OH minus is the acidic radical. So if the compound have OH minus acidic radical, then the given compound is basic in nature. What it is? It is basic. Okay, it is a base. It is a base. Okay, similarly KOH, that is potassium hydroxide. Okay, so K plus is the basic radical and OH minus is the acidic radical. Again, it is also a base. Then calcium hydroxide, Ca plus is the basic radical and OH minus is the acidic radical. It is also a base. Then ammonium hydroxide, NH4 plus basic radical, OH minus acidic radical. It is also a base. Now next you can see NaCl. We all know it is a common salt, molecular formula for common salt, and the molecular name of this compound is sodium chloride. Okay, the molecular name is sodium chloride. Now Na plus is the basic radical and Cl minus is the acidic radical. Okay, now both the radicals, that is basic and acidic, in both the radicals you will not see H plus ion and OH minus ion. That means it is neither acid nor base. So sodium chloride is neither acid nor base. In that case it is a salt. What it is? It is a salt. Okay, so this is the first example that we have seen of a salt, and we all know that common salt, so definitely it is a salt. Okay, then CaNO3 twice, so calcium nitrate. Okay, so Ca is Ca plus is the basic radical and NO3 twice is the acidic radical. Okay, it is also a salt. Then K2SO4, that is potassium sulfate. K2 plus basic radical, SO4 minus acidic radical, and it is also a salt. Calcium chloride, Ca plus is the basic radical, Cl2 minus is the acidic radical, and it is also a salt. Then NH4 twice SO4, that is ammonium sulfate, whereas NH4 twice is the basic radical and SO4 is the acidic radical, and it is also a salt. Okay, so we have seen examples of acids, examples of base, and we have seen the examples of salts. Okay, so these are nothing but acids, these are the bases, and these are the examples of salts given over here. What we have come to know by studying all this, that in acid you will find H plus as the basic radical, then in base you will find OH minus as the acidic radical, and if in the compound there is neither H plus nor OH minus radicals, that means the compound is a salt. Okay, so this is about the salts. So in this lecture we have seen, okay, we have gone through the examples of acids, bases and salt. Now we are going to discuss about these compounds. All these compounds are nothing but ionic compounds, okay, which have positive and negative charge particles or elements. Okay, so if the compound have positive and negative charge in it, that means they are ionic compounds. So we are going to discuss the ionic compound in the next lecture. For this lecture, your homework is you have to complete this table. You can complete the table in the textbook itself. Okay, so write down the name of the compounds, basic radicals, acidic radical, and also mention the type of all these compounds. Okay, so we will study about the ionic compounds in the next lecture in detail. Okay, until then, goodbye.